Hey, this is Math 6, Unit 1, Lesson 10, Bases and Heights of Triangles. So it says let's use different base height pairs to find the area of a triangle. So first off, we start off with an area of 12 activity. And it says on the grid, draw a triangle with an area of 12 square units. Try to draw a non-right triangle and be prepared to explain how you know the area of a triangle is 12 square units. So this is something that you did in class today, start off with. So we're looking to draw some sort of triangular shape that'll have an area of 12. So let's think back real quick. We've been working with kind of the formula for helping us figure out the area of a triangle, which we've already decided that if we took a parallelogram, for example, back to where we started, a parallelogram's area is found by doing a base times the height. And if we were to draw a diagonal line from vertex to vertex, we would have two identical triangles there, and so to find out the area of just one of those triangles, we would only need half of the base times the height to find out the area of a triangle. So if I know that I want to get half of the base times the height to be equal to an area of 12, then I need to think about what numbers can I multiply together and then divide by 2 to equal 12. Or another way of thinking about it is this. If I wanted to, I could multiply both sides by 2 to eliminate the half there, so that the base times the height is going to be equal to 12 times 2 is 24. So as I'm thinking about triangles to construct, I want to make sure that when I multiply the base and the height together, the two numbers are multiplied together, the product of those numbers is 24. So what are some possible options here? I could think of something like 24 times 1. That would certainly get me 24. I don't know if I have enough grid spaces there to get a 24 by 1 triangle. I could do 12 times 2 to get 24. I could do a 6 times 4 that gives me 24. And I can also do, should have done a different order, an 8 times 3. So let me erase that order just real quick, just so it looks a little bit nicer for you guys. So it's 24, 8 times 3, and 6 times 4. So those all equal 24. So those are 4 different, and really 8 different triangles I can draw, because I could also do 4 times 6, right? And keep on going that way. So I can continue on. So let's just pick one. I'm going to go ahead and do the 6 times 4 as a triangle I'm going to use to make one that's 12 square units. So I'll make a base of 6. So here's 1, 2, 3, 4, 5, 6. There's my base of 6. And all I want to do, I don't want to make a right triangle. If I made it right, I would go up 1, 2, 3, 4 to there. That'd be a right triangle. So I can actually pick any point along this line. I could pick one right there if I chose to. And I can make my triangle have a height of 4 by going up to that point. And draw those there, connect the dots. Right, and so my height of 4 is here. And that's my height equals 4. And so in this case here, I'd have a 6 times 4, or a 1/2 of the base times the height, which is 24 divided by 2 equals 12. And that becomes my area there. So it does work, and there's lots of options, and you could have chosen 24 by 1, 12 with a height of 2, 8 with a height of 3, or 4 with a height of 6. Lots of options there. Okay, so that's just one way of looking at that one there. Let's look at the next activity. The next one is called Hunting for Heights, and it says here are 3 copies of the same triangle. The triangle is rotated so the side chosen as the base is at the bottom and is horizontal. Draw a height that corresponds to each base. Okay, so what we're saying is we have the base here, and each of these are going to be a base. I'll make the base blue. Alright, so there's my base on this one. Here's B as the base there, and here's C as the base here. Alright, so to make this a height, I want to make sure that I have a 90-degree angle. It says to use an index card to help you. And the reason we're going to use an index card is because an index card ends in a corner, and so if I have a corner like such and like such, then I end up with a 90-degree angle there. So In this first triangle shape here, because I have a vertex that is across from the base and it's inside the base's area, I can simply line up the bottom of my note card with the base until I get the side to be matching the vertex there. And then I can draw a straight line down. And now I have a height right there for that one. No problem at all. Okay, so that works pretty easily there for that first one. But let's take a look at B. For B, I have to use the vertex that's opposite of the base, but obviously that's not going to be a 90-degree angle. So I'm going to need to come down. But if I just drew a line down, I don't know for sure if it's going to be a 90-degree angle. So what I'm going to probably want to do here is, if I kind of use my card, I can push my card out along the line of the base, which is here, and then get to the vertex, which is there. And what I could do is I can extend my base out to know where that's going to go, and I can extend a line from the vertex down to that base using the corner of my index card, and that gets me a height right here that corresponds to the base B right there. Okay, so that's what I did there. If you wanted to, you could have first of all extended the base out. Another way of doing that, if you extend that baseline out, then at least you know where you can go to, and then you could do your card like so and push it right there and draw your line down that way. Okay, in fact, let's try that for this one here. I think it's a little bit easier to work with your card. I'm going to, first of all, I see that C is here. My vertex that I have to utilize is across from it right there. So let's just extend this baseline across like so for now. Okay, and now knowing that that's the case, I can take my card along that baseline until I get to the vertex right here. I'm on the baseline here, and vertex there, and we'll just draw a line down, and that becomes my height for that triangle right there. Okay, so that's the idea for what we're going to do there. So at this point here, we have labeled it, we have our heights, and we're good to go. Okay, so let's look at the next activity. It says draw a line segment to show the height for the chosen base in each triangle. So using the same strategy with the index card, we're going to do that here for these guys here. Alright, so again, let's go ahead real quick. I'm just going to color my bases just so we can see what we're working with. I'm going to make my bases blue. My base blue. My base blue. I have a base here that's blue. A base and a base. Alright, so I want to make sure that I have that 90-degree angle coming from the vertex. Just to make sure we're clear real quick, I'm going to just highlight my vertex across with the highlighter, just so I know where I'm starting from. That's my vertex there. This vertex is here. The one that's across is the one that's actually right here. The one that's across is here. And the one that's across is here. So my height needs to come from somewhere along that vertex point. Alright, so again, using the note card, this first one is pretty straightforward. We put our card on the base, and we line up the edge with the vertex, and we just draw our straight line down for our 90 degrees. Okay, that's no problem there. And this next one, same idea. I can see that the base is crossing the vertex here, so again I can get my index card on the base line. There's a baseline there, and I can draw a line from the vertex straight down to the base, and there we are right there. On this next one, I'm going to extend the line first of all. Okay, I'm going to extend my baseline just so I can see what I'm working with. There's my baseline. I can see that when I use my index card and I line that up, when I hit the vertex, I notice I'm outside of the area of that triangle, and that's okay. It just means my height is going to come down over here, and it'll be on the outside, and that's where the height is going to be for that one, and that's okay. And often we indicate this with a dashed line so we don't get our lines confused there. On this next one, we actually have a right triangle, so I can simply just use the one that's right here and call this my height. No problem. For E, again, we can see this is the angle I want, but I can't get a 90 degree going toward the base or straight at it. So let me extend my baseline here. So I got that in place, and then we'll use the index card and then line it up. And once we get it lined up, we can draw that line from there to there, and then we have the 90 degrees. And this one here, it's already 90 degrees there, but I need to make sure that it gets my baseline here, so I'll use the edge and use the corner of the index card to draw the line, and we have our 90 degrees. Alright, so that worked out pretty well there. We have all of our heights which come off of that or near that vertex, and they make the 90 degree or the perpendicular line that either touches the base or at least lines up with the base. And that's the idea for all of those. Alright, let's turn the page and see what the next thing said to do. It says some bases are better than others, and this is very true. Some bases are a little better than others, and so we'll show you why with this next one. It says for each triangle, identify and label a base and a height. If needed, draw a line segment to show the height. Then find the area of the triangle and show your reasoning. Okay, so what I noticed first of all with a couple of these is on this front, for example, it's pretty nice to recognize that the base is this horizontal line and our height is going to be this vertical line here. That's pretty straightforward, right? And so here we have a base of 1, 2, 3, 4, 5, 6, 7, 8, 9. So our base equals 9. Our height is a height of 1, 2, 3, 4, 5. And so we could use our formula to find the area. 1/2 times 9 times 5. And 9 times 5 is 45, right? So we have half of 45. And half of 45 is 22.5. That's the area of that triangle right there. Okay, but I have a nice grid to work with because of the grid lines to get a base and a height there. On this next one, I have a nice horizontal line here, and so I could use this as the base. It has a base value of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our base is going to be 11. And again, this is my point, my vertex I'm dealing with here. And so I would technically come down all the way to here and all the way to here to make my height this line right there. And what is this height going to be? It's 1, 2, 3, 4, 5, 6, 7, 8. So we have a height of 8. So my height equals 8 on this one right here. And so as an area, we would do 1/2 times the base, which is 11, times the height, which is 8. I'm going to look first of all, I'll do the half of 8 is 4, and then 4 times 11 is 44. So this has an area of 44 units squared, or square units. When I look at C, we have this vertical line here. We can call that the base, and we can have 1, 2, 3, 4. The base equals 4, and then we can come down off of this vertex point here, straight along there, and make that our height. So that has a height value of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Nice and long. So a height of 18. And so again we would say it's 1/2 times the base times the height. So 1/2 times 4 times 18. Alright, so I could think about half of 18 if I want to do that first. Half of 18 is 9, and then 9 times 4 is 36. This would be 36 square units. And then for our last one here, we have a base handy here. 1, 2, 3, 4, 5, 6. Base equals 6. This line, this grid line, fortunately looks like it attaches to our vertex, which is really convenient for us. So we can call that our height. So it has a height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is our height here. And so the area would be 1/2 of the base times the height. Half of 6 is 3. 3 times 11 is 33. So we have an area here of 33 square units. So those ones are nice. They're easy to do because we're using the grid lines on the horizontal ones here or the vertical ones to make a nice base. But let's take a look at this last one here on the Are You Ready for More? And I think it's a great question. It wants you to find the area of the triangle below. And it's a great question because we can see it doesn't utilize one of the vertical grid lines or the horizontal grid lines. So it makes things a little bit more complicated. So one way you might go ahead and solve this one would be to simply enclose the whole square. Enclose the whole the triangle in a large square. And by doing this, because we're using the grid lines, we have created 3 different triangles that all utilize the horizontal and vertical grid lines. Okay, so as a square, this has an area. The area of the square is going to be equal to base times height. Well, we have a base of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we have a height of also 12. So we have an area of 144. But we're going to want to go ahead and subtract this space, subtract this space, and subtract this space to see what's left. So we can do that by determining the area of this triangle, which has, we can call this a base of 1, 2, 3, 4, 5, 6, 7. So 1/2 of 7 times this height, 1, 2, 3, 4, 5. Oh, weird, now it's 12. 12. All right, half of 12 is 6. 6 times 7 is 42. So this has an area of 42. Over here we have 1, 2, 3, 4, 5, 6, and a height of 12. So we have 1/2 times 6 times 12, and half of 12 is 6. 6 times 6 is 36. So we have an area here of 36. And over here we have 1, 2, 3, 4, 5, 6. So 1/2 of 6 times the height of 1, 2, 3, 4, 5 times 5. Well, 6 times 5 is 30, and half of 30 is 15. So we have an area of 42, an area of 36, and an area of 15. We add that up, we have 11, 12, 13, carry the 1, 7, 8, 9. So we have 93, an area of 93 that we're going to have to subtract from that from the large square in order to figure out what's left. So when we do that, 4 minus 3 is 1, and then 14 minus 9 is 5. So what I'm left with here is the area of the blue shaded area is 51 square units. Great question, but you can see I had to do more work on this one because it didn't have a base or a height that followed one of the, or base or height that didn't follow the horizontal or vertical grid lines. All the ones above did, and so it made them a lot easier to solve. This isn't any larger of a triangle really than the other ones. It's almost the same size as the 44 one, but just the way it's shaped makes it a little more complicated for us to solve. Alright, so in summary here today for today's lesson, we would say that a height of a triangle is a perpendicular segment between the side chosen as the base and the opposite vertex. And we can use tools like our card here with right angles to help us draw the height segments. And that's what we did there. The rest of the summary is just kind of showing you an example of how you draw those heights utilizing an index card, right? How you might find a vertex and slide it over to draw that line to make it the way it's going to be, just like we did in our practice together. You can also do it the ones that extend outside by drawing that line, pushing it across, drawing the line when you get to the vertex, and then move your card back to see what you have there. Okay, so just good practice there. And then again, if a triangle is on a grid and has horizontal vertical side, you can use that side as a base and use the grid to find the height. So it's really handy when it does have a grid and a line is actually on one of those grid lines there. So that's a really good useful tool. Okay, we're going to pause there. You're going to start your homework, and then we'll come back and check it together in just a second. Alright, so here we go. Looking at our homework from tonight. It says for each triangle, a base is labeled B, and draw a line segment that shows its corresponding height, and use an index card to help you draw a straight line. So, like we did before, we can see that our bases are going to be these guys right here. A base, and a base, which means that our corresponding height needs to come off of the vertex that is across from our base. So I can just highlight those real quick for you before we start anything. Alright, now this one happens to be on the inside of the triangle, so that's a pretty easy line to draw for us. We'll take our index card and we'll go from the vertex straight down to the base and indicate that's a height with a 90-degree angle showing it's perpendicular. This one here, similar idea, right? We can use our index card, run it along the baseline, and then line it up with the vertex to draw a nice straight line. Hopefully I can do that. And 90-degree angle like so. This one, that was a little different, right? I can't run that at 90 degrees there. So what I'm going to do is I'm going to go ahead and first of all extend my base out to a place where I know that my vertex can line up there. So then I'll come this way and line up the bottom of my card with the baseline and the vertex, and then we'll extend like this, and we'll have a height that's outside the triangle there. So there we go. Those are our three heights like so. Alright, on the next one, I'll zoom in a little bit, sorry. It says select all triangles that have an area of 8 square units. Explain how you know. Alright, so this first one here, we have a base of 1, 2, 3, 4, and a height of 1, 2, 3, 4. So that would be 1/2 times the base times the height. And half of 4 is 2, and 2 times 4 is 8. So that one's going to work out just fine. Here we have a base of 1, 2, 3, 4. So we know it's 1/2 of the base, and we have a height. I can see the vertex here is inside, so I can draw a nice height line there. And our height is 1, 2, 3, 4. So it's the same thing. So 1/2 of 4 is 2, times 4 is 8. That's going to work out just fine as well. On this next one, we see that the base is here of 1, 2, 3. So I have 1/2 times 3. And the height has to be outside, which is just fine, coming down this vertical line there. And so we have a height of 1, 2, 3, 4, 5. Alright, so this becomes 15, and half of 15 is equal to 7.5. So that's not going to be 8. And on D, we have a base of 1, 2, 3, 4. So 1/2 of the base. And the height here, again extended on the outside all the way down, matching up with our base there. We have a height of 1, 2, 3, 4 again. So the same numbers, 1/2 times 4 times 4, which again still equals 8. So that works out great. And here we have a base of 1, 2, 3, 4, 5, 6, 7, 8 is our base. So 1/2 of 8 times the height, and there's my vertex. So I draw a height line there, which has a height of 2. And 1/2 times a 2 is 1, times 8 is 8. And that one works as well. So most of them have an area of 8 square units, with the exception of C. Alright, number 3. Find the area of this triangle and show your reasoning. If you get stuck, carefully consider which side of the triangle to use as the base. Alright, remember what we talked about before, it's easier to use a base that is on one of the grid lines. So I'm going to choose this line right here as the base. 1, 2, 3, 4, 5, 6. So my base is going to be here with 6. I'm going to then choose, if that's my base here, and again if I was to highlight that with the blue, then I would choose the vertex that's across from it to utilize as my height. In this case here, it's going to be right inside of it, no problem, for a height that has a value of 1, 2, 3, 4. So my height equals 4. So I would do 1/2 of the base times the height, and half of 6 is 3, and 3 times 4 is 12. So we'd have 12 square units would be the area of that triangle, using the side as the base there. Works a lot better than something else. Okay, let's look at the next page. Number 4 asks, can side D be the base for this triangle? If so, which length would be the corresponding height? And if not, explain why. So the question is, can I use D as a base? Can I use a D as a base? Well, to answer that, we've said before that any side of a triangle can be used as a base. So it can be, that's for sure. We know that. You can use any side as a base. So for the first question, we would say, yes, it can be. Now, if so, what would the height be? Well, we'd have to take a look at the vertex across from it, the vertice, and when we look there, we notice that I could potentially draw a line here, straight down, and make that 90-degree angle. But it's not there, but what do you notice? This line sure does look a lot like that line, doesn't it? And that's because we've extended a line from the vertex across from it, we've extended the base, and we've drawn a perpendicular line here. So this letter G is the same as this line here, which I drew. So the corresponding height would be G. And it works out just fine. All right, number 5. Number 5 says, find the area of the shape and show your reasoning. So when you look at this, you might think, well, can I chop it up into some triangle pieces? What can I do? And, you know, different things. So you have to kind of look at what do you see here. And when I first saw it, I thought, well, maybe I should draw it as a triangle, but that's going to be a really weird shape. That's not going to work out well. Maybe I draw it as a trapezoid and chop off things. That's going to be weird. And I thought, you know what? Let's go back to making a larger shape and then erasing or deleting the parts in the middle. Okay? So this larger shape has a base of 1, 2, 3, 4, 5, 6, and a height of 1, 2, 3, 4, 5. So this larger rectangle has an area of 30 square units. Now if I was to subtract the triangle and subtract the other triangle, then I would end up with whatever the value is of that other funny shape, wouldn't I? Okay? So if I subtract this and subtract this, it'll give me what's left on the inside. So what's the area of this triangle right here? That would be 1/2 of the base, 1, 2, 3, 4, 5, 6, times the height, and here's the vertex right here. And we can see there that it has a height of 1, 2. So 1/2 of 6 is 3. 3 times 2 is 6. So one triangle has a value of 6. We can draw 6 there. And over here we have 1, 2, 3, 4, 5, 6, and a height of 2. That one also has a value of 6. It's the same. 1/2 times 6 times 2, which equals 6. So we have combined 6 and 6 is 12. Right? And so if I subtract that from the whole rectangle, 30 minus 12, that will give me the area of the zigzag piece. It has an area of 18 square units. Alright, number 6. On the grid, sketch 2 different parallelograms that have equal area. Label a base and a height of each and explain how you know the areas are the same. So, what you want to first of all do is think about an area you want to use for a parallelogram. I went ahead and chose a number we've used a few times, which is an area of 12. And to do that, because it's a parallelogram, I'm thinking about a base times a height, oops, not a 4, a base times a height, that's going to equal 12. So for that, I could have 6 times 2 equals 12. I could have 4 times 3 equals 12. I could do 3 times 4 equals 12. I could do 12 times 1 equals 12. So a lot of options there. Okay? For now, I'm going to go ahead and use those two just for my example. So first, let's draw a parallelogram with a base of 6. 1, 2, 3, 4, 5, 6. And a height of 2, I can go up here. 1, 2. I have a height of 2 right there. 1, 2, 3, 4, 5, 6. My other parallel lines can be there. I connect the dots. And I have a base equals 6. And a height equals 2. For this next one, I can do a base of 4. 1, 2, 3, 4. And I can do a height of 3. I don't have to go right next to it. I could come over here a little further. In fact, I could actually go to this last one. 1, 2, 3. It'd be kind of fun, right? And make my height line right here. and then extend this over 1, 2, 3, 4, and then play connect the dots. So here's my base of 4 and my height of 3, so I also have an area of 12. So just a couple examples. Are there other ones you could draw? There certainly are. That's it for today. Have a great day, and we'll see you next time.